Good evening, everyone. Thank you for your attendance this evening for the talk with Dr. Yuhong Lu. My name is Imtisal Ahmad, and my pronouns are she and her. I am the 2022 Women in Engineering Chair at the IEEE Northern Canada section. I'm currently in my final year of computer engineering at the University of Alberta, so this is like a very nice opportunity for me to learn. I am really pleased to host this event on behalf of the Educational Activities Committee. I would like to thank my co-hosts this evening for their support, Clara, Kellermann-Bryant, and Gobi. If I mispronounce your names, I'm sorry. Ramasamy. Please introduce yourselves.
I'm Clara Kellermann-Bryant, and I am a graduate student at Southern New Hampshire University, matriculated in their Cybersecurity Master's program. My areas of focus include secure software engineering, information security research, and leveraging security for businesses. Our other member is Gobi Ramasamy, who is a professor in computer science at Christ University, Bangalore, who has taught students applicable fundamentals to the computer science and information technology industries. Dr. Yuhong Lu from the Department of Computer Engineering, Santa Clara University of the United States of America, has come to join us. Dr. Yuhong Lu's research interests include trustworthy computing and cybersecurity of emerging applications, such as Internet of Things, blockchain, and online social media. She has published over 60 papers on prestigious journals and peer-reviewed conferences. She is currently serving as the chair of IEEE Computer Society STC Executive Committee Board, the vice chair of the Special Technical Communities of the IEEE Computer Society Member and Geographic Activities Board, and a member of the IEEE Computer Society Technical Meeting Requests Committee. She has also served as a member of the Multimedia Security and Forensics TC for Asia Pacific Signal and Information Processing Association since 2019.
Was that a good enough introduction, Dr. Lu? Would you like to add something to that?
Oh, that's perfect. That's thank you so much.
Perfect. Without further ado, we would just like to dive into questions now, if you're comfortable with it. So we're going to start really general. So how are your research interests integrated into the courses you instruct?
So at our university, I'm mainly teaching two different courses related with cybersecurity. And one of that is for undergrad level. That's introductory class about computer and network security. And the other one is more like advanced lecture for the grad master students or PhD students. That is for trustworthy computing. And for the introductory level for undergrad students, my goal is to just help the students get to expose to some general fundamental cybersecurity concepts and hopefully attract their interest to further pursue knowledge in the field. So that's why I consider interest is the most important thing. I want to, help the students to start to, dive into the field. So since some of my research are more like kind of a little far away from daily life, and some of them are, related closely with students' daily life. So I tend to use those daily life examples to kind of help students understand what are those cybersecurity problems they may encounter every day. For example, like the online social network, they use that daily. They share their photos, videos, and talk to their friends all the time. So that actually makes them kind of a little more vulnerable to potential attacks about their privacy. And also, they may be exposed to one of the most important things today, that is disinfo and misinformation. They may even unintentionally participate in the propagation of some untrustworthy information. So those are their daily lives. I often use those as some motivation examples to help students understand. And beyond that, we also have the hands-on projects closely connected with the theory part we introduced in the lecture. So hopefully students, through those experiments, those hands-on experiences, can understand more about the practical aspect of security, because eventually you have to be able to manually work, be able to kind of protect your system by yourself. Yeah.
How do you motivate students into pursuing these topics?
Yes, actually, I think this question is kind of connected with the previous question. I kind of mentioned that I motivate them through some everyday life examples, and also introduce them with some hands-on labs and projects. And also in another course that I teach, like the trustworthy computing. I know, like recently, students are very interested in like machine learning, AI, because that's a really hot topic. So I do introduce like a term project that with some data analysis, machine learning, data mining as tools to help attract students' interest. But really, the goal is to solve a cybersecurity problem. So, for example, I share some initial data sets with the students regarding like disinfo, misinfo, and they need to apply, for example, deep learning tools or machine learning tools to kind of differentiate the truthful info from the malicious info. And through that process, I think students kind of learn the concept and know that actually different domains or different tools can actually be combined to achieve one goal. So that's how I motivate my students.
Yeah, the next question is your research interest, expertise in online social network security, privacy, trustworthy IoT, trust management, blockchain, and so on. What motivated you to, at a personal level, to pursue these research interests?
Yeah, so it seems like my topic kind of covered some different areas. So that was an interesting journey, actually. Back to my master degree, I was interested in a project as a peer-to-peer network project. Back then, like 2004, peer-to-peer, the concept was very popular. And it was used a lot for file sharing in decentralized systems. And I was also interested in that project. Through the project, of course, I learned a lot of different concepts about decentralized computing, parallel computing, etc. But one important thing I found interesting is the coordination and the collaboration among different parties, different peers, when they participate in the network. And interesting thing is, one of the most challenging thing in a peer-to-peer network is how can you encourage people to participate and contribute. Not everyone is, just to do things for others. Most of the users, they are selfish, right? We have our own interests and we want to maximize our own benefits. So there could be like free riders. And if the majority of the network, they are just the free riders, you can hardly imagine the system will run forever, right? Or run in a good shape. So that becomes a very challenging, interesting, but challenging question. Then starting from my PhD, actually, the topic I started working on was like trust modeling with a particular application domain as the online social network. From that domain, we actually try to understand the users' behaviors. And an interesting thing that started to connect is the online users, they are often of the time also selfish. And even worse, some of the users are malicious. They are attackers. They try to grab sensitive information from other users, or they try to do something bad. So what I did for a PhD study is kind of using some tools, trust modelings, to actually estimate or predict users' behavior. Try to differentiate those, normal user or honest user behaviors from those malicious ones or selfish ones. And one step further, even like try to provide incentives to encourage the users to behave in a trustworthy way to contribute to the network and facilitate other users. So that starts to connect. And that's actually the major topic for my PhD. But then I graduate and actually got a job in academia. So in my future, like directions, I was wondering, how can I utilize the knowledge I have to actually look for new problems? And it turns out the trust modeling can be generally applied in much broader application domains. So as long as there is a network or a system, there are multiple agents, either human user or just machine. As long as they participate in the system, they may have different interests, they have different goals, then that can be modeled like multi-agent system. And then trust modeling, which can inspire or encourage the participants to collaborate together, and while at the same time try to help them achieve their different goals. That become like a general tools to play a role. So that's how I start to find this is a very good direction to be generally applied. And I found it particularly useful for example, cyber physical systems or Internet of Things, and blockchain systems, those like decentralized systems where you have different parties. So that's generally how I get into the field, and I still feel passionate about this field.
It's really trustworthy in listening.
Thank you.
Did you have any mentors in this journey? How did they inspire you?
Yeah, for sure. I feel I'm very lucky. I have quite a number of good mentors who helped me, find out the way I want to pursue. So first one I want to mention is my PhD advisor. She's actually my role model. Yeah, she did very successful in her career. And well, technically, I learned from like how to do serious research from her. I closely worked with her just as her student for 5 year plus 1 year postdoc, so altogether 6 years. And she taught me, like, for example, how to perform like comprehensive literature survey, how to do solid experiments design, and how to do the results analysis, all those technical stuff. But more importantly, she also helped me for example, know that as a PhD, close to graduation, you need to be able to do independent work. You need to be able to, for example, identify an interesting, important problem that you can work on, and think about for the next 5 years, what can you work on? For the next 10 years, what can you work on? And so those are very helpful suggestions for me, like keep me thinking, what can I do for the future? And also, there are some other skills that I learned from her. For example, how to do public presentation. You do all the solid work, you get publications, but still you need to talk to people to help them understand what you are doing, so that you can see other opportunities. So I think those are also very helpful skill sets that I learned. And then later, when I started my career as a professor in university, I found many of my colleagues, they are very helpful. They are generous in terms of sharing their experiences with me, not only on research but also teaching, service, work-life balance. There are a lot of challenging issues when you start your career in academia. For example, like I graduate as a fresh PhD. I have no teaching experience at all. How can you, attract your students in your class? Not just, teaching them in a very boring way. People will never learn that. So I had a few colleagues. They are very good teachers. They know how to attract students' interest, while at the same time also be able to pass the knowledge to the students. So I learned a lot from them as well. Then the other side is, how do you balance your work life? Starting as a assistant professor, you have a lot of different things you have to learn. You have to develop your independent research, your teaching skill. Like, you also need to go to conferences, get to know people. There's a lot of work you have to do. And also one thing is, how do you say no to all those different tasks? That's an important skill as well. So yeah, I initially didn't do a very good job, but I was learning on my way. I talked to colleagues from my department, from some other department in the school, and also our university. They provide very good opportunities for us to participate in the national level, like faculty development programs. And I got the chance to talk to other faculties from totally different disciplines from another institution. So I share my experiences and also learn their experiences. So I think that's very helpful and very how to say it? I would say I get to know some very good mentors that help me pass this challenging stage. Yeah.
That's wonderful. I'm just going to pivot back a little bit to blockchain.
Yeah,
so
sure.
What are your predictions on blockchain for the future?
Yes. So for the past few years, we have seen the rapid growth of blockchain techniques, and starting from the digital currency, cryptocurrency, Bitcoin. And nowadays, blockchain has already been adopted in quite a few different fields. For example, like decentralized finance, DeFi, or GameFi, like use that for decentralized game platforms, and even NFT. So those are like popular areas that blockchain can already play an important role. Well, recently, there are some emerging application domains as well for blockchain. For example, like the DAO, the Decentralized Autonomous Organizations. You probably have heard about that. So traditionally, when you have some fundings, it's typically through you have to do the investigations. You have to do the financial investment through like a central party. But then there's a lot of issues regarding like transparency, the organization management, right? So like as an investor, you may not even know how important decisions were made. So blockchain actually provide like a public, open, and also be like a transparent way for you to verify what's going on. So that's a very important different tool that is from the existing technology. So I can see blockchain in the future may be able to play an even more important roles for like a infrastructure, fundamental computing infrastructure for many other applications as well, because it provides like open structure and it's decentralized. Suppose everyone should be able to participate, and everything going on there can be publicly verifiable. So I would imagine it can serve as a trustworthy computing platform. And of course, there are many challenges as well, like the performance, the throughput, scalability issue, and also security issue as well. So the recent hack of the Luna digital currency led the stock market dropped significantly. That was a damage. So starting from this stage, I think cybersecurity attracts even more attention, because for blockchain, like there's real or a significant amount of finance or money involved. So when security breaches occur, it will be significant. And another thing is there are many digital currency, cryptocurrencies in the world right now. But the problem is they never talk to each other. For example, I learned the data like early this year, there were more than 11,000 different digital currency available. So among them, how do you choose what, and how do you know which one is secure, which one is not? It's a very challenging question. And also another important problem is they don't talk to each other. They are kind of isolated. So the interoperability is another issue. How do you enable different, for example, as a user, I may invest in multiple digital currency. How can I convert one from the other? Right? That's an important issue. And this conversion or interoperability raise another challenge for security because they are heterogeneous. Some currencies may be more secure, some may not, right? While you allow this free flow, then some less secure currency may actually try to bring even more security vulnerabilities to other currency as well. So there's a lot of things or challenges ongoing, and we need further development in the field for sure.
Thank you.
How can blockchain technologies be accountable for intellectual property?
So I'm not particularly working on the intellectual property, so I will just try to explain from my own angle. It may not be complete. So in my opinion, as we mentioned before, like blockchain can serve as a public ledger. So it basically provides a whole complete history, trackable history for any digital items. And then it may provide a way to protect the intellectual property so that people can actually trace back to the real original source, so that you cannot actually fake or manipulate the overall history. That's my understanding. And another important thing is, although blockchain can be, generally publicly verifiable, but it doesn't mean that everything on blockchain is in plain text. We still can utilize the cryptographic-based algorithms or protocols, for example, like zero-knowledge proof, to provide privacy protection. So the users, although their data is on-chain, they don't have to expose that to everyone. That's my understanding.
Thank you. And within your expertise of social network security and privacy, what are the major challenges you have encountered?
Yeah, so I have worked on different specific problems, like including the online reputation system, online rating system. People may provide fake ratings or reviews to online products and services. And I also work on social network communities, right? How do you detect social communities? And recently, one of the major problems I work on is the misinfo and disinfo problem. Actually, in this problem, you see that human users, they are vulnerable to the misinfo and disinformation. And also there's a lot of different parties at the back end trying to push the propagation of disinfo and misinfo. So different from the other multi-agent systems, in the online social networks, we have a lot of human users. And they make their decisions sometimes arbitrary, sometimes based on their own personality, and sometimes based on different social or psychology factors. So it's a very complex and also dynamic system. How do we understand why, as a human user, you make such decision? It's kind of challenging. So with only the technologies or tools from computer science and engineering, that's not sufficient. I actually started submitting my NSF proposals by just proposing my own solution to that. But the feedback I got was how can you model human user as just static or some symbols or some fixed model? That's kind of impossible or infeasible. So then I started to talk to colleagues from other disciplines. And then I realized actually the human factor has been studied a lot in other disciplines. For example, sociology, psychology. There are experts focusing on the disinfo and the misinformation domain. So I started my collaboration with them. And for example, I collaborate with a professor from a social psychology perspective. We try to understand now why people will participate in the trolling, online trolling, and then for example, how do they perceive the emotion? If the emotion change will lead to different behaviors or not, and if yes, why? And we started to start from those fundamental or little specific problems now. And we are making progress little by little. And I also work with journalism, another researcher with a journalism background. So for example, we study what is the ethics of the journalist, right? What should be their responsibility to kind of first, address the problem. So there are so many different angles I learned from all other colleagues.
That's great. Just before we go for break, I have a follow-up question to that. How did you overcome them, and what were some lessons you learned? What advice would you give to your younger self?
Yeah, I think I kind of touched that a little bit. Just talk to more
Go to
people.
different professors.
Right.
Other
Talk to
areas,
people
right?
with different background. Yes, exactly. And so another thing, I think my advice would be like keep your curiosity. Do not just focus on your narrow specific problem, because that can make your mindset very narrow. You may be blind to all other fields. And talk to people, get to know them. Don't limit yourself. I remember one thing I learned actually from a conference when I participate during my PhD. But I learned the concept, never get a chance to practice. Now I think I start to remember that. It was like they did some study on the general scientific research publications. And they figure out it's interesting that it's very difficult for researchers from different disciplines to collaborate. But if they are able to collaborate, it often can lead to very impactful research. So that's a lesson I learned.
That's great. Do you recall what conference it was? Was it recent or?
I think it's kind of related with some machine learning conferences. And they use real data, and apply machine learning models to, really tell what are the impactful research. And they found this interesting pattern. So that's very impressive.
That's wonderful. I think this is a good spot to take our 5-minute break. And then we will all kind of join in at 3:35 your time, Dr. Lu. Does that work?
Sure.
Perfect. Start your
Yes.
See you all in a bit. Bye.
Let's go. What data security approaches can be used to protect online social network privacy?
So there are several different aspects. From the regulation point of view, there have been some regulations developed already. For example, the EU, they have the GDPR, which is already kind of well known by, international companies, for example, they must comply to that regulation. And also in the US, in California, we started to have the CCPA as well in place, I think at the beginning of 2021, around that time. Yeah. So those are very good steps or efforts that made by the government. And on the other hand, we also need the technical solutions, technical tools. People are actually studying this for quite a long time. For example, some technologies include like the differential privacy, and or like from machine learning point of view, nowadays people tend to use share their data. They have train together, right? But how can you, for example, without getting the detailed raw data from the individual users, but still include their patterns in your generally learned machine learning model? So federated learning could be a good way to do that. So individual users, they just need to train their local model and only pass the model parameters to the central party. And then the central party will aggregate the parameters learned from different individuals. So they don't have to, look at your raw data. Another angle is also for the online social media platforms. They collect a lot of their user data, and they're responsible to protect that data. And one common practice is they may sometimes need to outsource the data to some, third-party cloud computing services. So in that case, they have to encrypt the data before they outsource the data. And another challenge then become like, if they need to provide services to the individual users, how can they process the data? So you have to have some technologies to support some operations on top of encrypted data. So like secure multi-party computation or homomorphic encryption, those techniques are also developed. So there are some technical aspects as well. They're making efforts. But I would say eventually the most important thing is still individual users. We pay attention to our own data. We have to be aware of, the data privacy issue. So because eventually a lot of things operations are made by ourselves. For example, like when you register an account from an online social media platform, they may give you their privacy policy, right? You need to check the policy and make sure you understand what's going on, right? And also when you go to another like websites, there are like cookies, right? You have to make careful choices about your cookies. Otherwise, it will be able to track a lot of your information. So another thing is try not to post everything online, especially your sensitive personal information, right? Another thing is this is interesting. A couple of years ago, we did a study with the real online social user data. We focus on the user friendship relation. So, for example, we may not want to reveal all our friendship relation to the general public, right? And then, but from the social network perspective, they want to reveal more information so that they can attract, for example, potentially user A and user C. They may not be friends yet, but they may have someone in the middle who knows both, right? So there's a high chance they may get in touch if the social media platform let the other two users know they have a common friend, right? So that's some, conflicts. There's some conflicts there. And we did a study say if we allow the individual users to actually make their own choice about how many friendship relationships they want to reveal to the general public, right? Can we achieve that? So that's a study. And it turns out that if in those friendship relations, the privacy, it's not only depending on your own settings, it also depends on your friends, their privacy settings. If they decide to reveal a certain relationship, right? If they make very relaxed, restrictions on who they can reveal, then your relationship may also be revealed as well. So your privacy is not only controlled by yourself, it's also on the hands of your friends. So be careful about who you connect with. Yeah. And also try not to, accept those random, arbitrary, unknown friend requests. That's another way to protect yourself.
Thank you. What are the emerging threats against social network security, and how can users stay informed about protecting themselves?
Yeah. So this is a very interesting thing. There are a lot of threats against the social network. Like one of the already kind of very commonly recognized one was different from other systems. Online social network, you tend to trust the people you connect, right? Your friends, your family members, or some other people you share common interest. So then the malware also found their way to propagate through online social media. That's much more efficient than the propagation through spam email or some other ways. So that started to become very popular and prevalent. So then a lot of different techniques were actually developed to try to warn users. For example, if you receive a link sent by your friends, shared by your friends, right? Try not to click that directly. Make sure, double check it's from your friend, right? It's not a random link. Or sometimes your friend may, get account compromised, right? So the link shared by them may not be shared by the real person. So you should be aware of that. Don't just arbitrarily trust anyone. And another thing is, what more an emerging thing is about deep fake. So we know the technique, the development of deep learning, right? Now, and also multimedia, there are applications. So nowadays, people can easily make some deep fake videos or audios. For example, recently there was a deep fake video about Zelensky, the president of Ukraine. And in that fake video, he was asking his soldiers to surrender. And that got propagated on online social media. Although in the US side, most of the those fake video propagation was blocked or taken down. But in Russia, for example, that video got very popular, propagated on their online social media. So that's new technologies in the field that's threatening people's knowledge. Yeah, so for that one, it's until now it's still very difficult from the technology perspective for the defender side to actually be able to capture that. There were some very good studies that can accurately differentiate deepfake videos from the true videos, but it's typically in a lab environment. The technology is not mature yet to be applied in the wild. Like randomly, when you have a deepfake video, there's no guarantee we can detect it. So so do pay attention or be more aware of that. And similar thing is not only the video side, it's also about information, disinfo, misinfo. Those online social media platforms, the major ones, they already take a lot of actions to try to prevent such propagation, massive propagation. For example, they also generate like Facebook, Twitter, and even Google. They generate the tags to help mark this piece of information as unverified or it's possibly misinformation. Try to remind the individual users. But the problem is, I heard like the real world impact or the effectiveness is poor because when you get online social networks, there's like an echo chamber. You tend to be connected with people who share similar interests or similar mindset with you. That leads to your everything you see kind of echo what you believe, and you are blind about the other side. And because of that, there's a higher chance if all your friends, your circle, they are sharing something, even if that's not true, you may tend to believe it with a high probability. So the suggestion, another study we did recently was from different places, they tend to be more less vulnerable to misinfo and disinfo. So the suggestion for individual user is try not to stick with a fixed static source. Try to be more diverse about getting your information from. So that's something I think will be helpful. So sorry, I think that my network connection was not stable. Is that okay?
Yeah, it's fine.
Yes.
Yeah, I think we got the answer.
Yes.
Okay, perfect. Thank you. This is a lot of information, even for like me, like to go on social media. Follow-up question: how do you build trust on social network analysis?
Yeah, there are many different ways. I would just mention a few examples. So actually, for trust modeling, some of them are kind of intuitive, and hopefully, what I will mention will make sense to you. So one typical classic model is like direct trust and indirect trust. Direct trust means you make your own observations about a particular person or account or some source, right, object. So if you observe this object or this atom for like over a long time, and then you will have sufficient experiences to make your own choice. Sometimes if you don't have the chance or opportunities to make your own observations, you may rely on others. So that's what we call the indirect trust. Like, for example, recommendations, like online rating system in Amazon or eBay, right? If you haven't bought any online products from this particular vendor before, you may tend to look at their online reviews and ratings, right? So that's another way to help you build up your trust, whether this could be trustworthy or honest seller or not. So that's a typical model for direct and indirect trust. Another way is we can also, based on the statistic analysis or probability, like for example, Bayesian model can be applied. Based on the prior observation, we try to estimate in the next step how likely this user or this particular object will make a trustworthy behavior or will make a malicious behavior. So that's some statistic analysis. And a very well-known one was the beta trust model. So they model the user's behavior as just binary value. 0 means bad, 1 means good. Then based on the beta model, they would build up the expectation. So for the next behavior, what's the probability for that one to be a good one or a bad one? So that's a model. And beyond that, there are also other models. I just briefly mentioned the name. For example, or entropy-based model. So we consider if the user's behavior tend to be like higher entropy, that means less predictable, then that cannot be trusted. If the user behavior, there's a very low entropy, that means it's highly predictable, then that can be a trustworthy user. So some of the models are like that. And another important thing is trust can actually dynamically change over time. So it's just like a human world. When you know someone, right, but you haven't seen him or her for a long time, so your experience or observations about this person, like 10 years ago, right, should not have a very high impact on today's behavior or your expectation, right? So over time, we should gradually forget the experience we had like long time ago and pay more attention to the most recent behaviors. So that's another model we can consider. So there are many different models like that.
Thank you. Yes, this is a follow-up question. I mean, you also answered in between. From your own perspective, how we can secure the social networking apps? See, for the common man, the computer or the mobile app, security or privacy is a joke. That's what they are saying. So from your own perspective, how do you look into this?
Yes. So again, I also consider the mobile side, right? Because they have limited resources, computation, storage, all those things. So they have limited resource available for the security implementation. So that makes them especially vulnerable. And also, for example, when you use like an Android phone, for example, right? When you download an app, you need to make some basic settings. But most people just go with the default setting. They don't bother to, check that carefully. So, for example, like location service, right? That's closely related with your privacy. And they may, typically, well, if you go into the technical detail, that would be too difficult for individual user to understand. That's why people tend to, just go with the default setting. But nowadays, there were a lot of the efforts made already trying to make the understanding of what's the different settings more easily for the individual end user. But again, people may not bother. So for example, for the location service, will you grant the access of a particular app to your location or not? If the app is not related with location service at all, why do you allow the location service? And some other things, even if you allow the location service, should you allow that all the time? Or should you only allow that when the app was running for a particular purpose, right? So there are a lot of detailed choices you have to make. For example, another thing is, should an app be granted access to your contact info, your phone book, right? And those can always be the user's choice. And from the other side, the app developers, because that was kind of, easily granted. So most of the time they try to ask for more than they need. Because of that, it may also generate some vulnerabilities, right? They take care of your data. They have the data. And if they are vulnerable, if they have some, security vulnerabilities, it may make them, tend to lose your data to some malicious attacker, and that can cause damage as well. We had a previous project working on like Bluetooth security for mobile phone. And we found that in the Android system, for example, all the apps, they kind of share the same Bluetooth related, connection ID. So if one app, that's an official legitimate app, it can get connection with another device through the Bluetooth signal. The channel once established, all other apps, as long as they know the ID, they can also access the channel. So whatever you are transmitting over the channel, that can be learned by other apps as well easily. I don't say it is by default, but it can be, through very easy manipulation, you can achieve that. So imagine if the plain text is transmitted over the channel, then the malicious app can easily get what you are transmitting. So you'd better encrypt your data at the application layer. So even the channel is exposed to other malicious apps, you are still protected. So those are some of the suggestions.
Yeah. And also in reality, even if you take a talking Tom app, it also needs a location access. It also needs access to your contacts. That's the reality.
Yes.
Yeah.
They tend to ask much more than what they need.
Yes. Thank you for that answers. Yeah.
Just gonna pivot a little bit into Internet of Things. So can you share with us the critical research occurring for trustworthy Internet of Things?
Sure. Actually, for today, like a lot of people, they consider the IoT, Internet of Things, from a very different angle, I would say. Some people consider everyone or most people kind of agree that IoT devices, they are relatively less power, resource constrained. But even for that concept, people have different understanding. For example, someone may consider, like, compared to cloud computing, your desktop, right? That is IoT device already. And some of them may consider, like your cell phone, mobile phone is like considered as IoT device, right? And for our research group, we mainly focus on even like low power, low energy, resource constrained device, like for example, Google Home, Alexa, your smart home devices, right? And like light bulb, smart light bulb, right? Those are very low power. They have a limited resource. So because of that, it makes them kind of vulnerable to security attacks. They don't have too much resource to, just dedicated for security purpose. And also, there are like so many different manufacturers. They are generating those IoT devices, and they may use different chips, and the hardware could be different. The firmware, the software, everything is different. And sometimes even the same IoT device, they may have the software provided from different third party. So all of that makes the problem particularly complex. Then I think there's very challenging, if not all impossible, to actually have a general solution to address all. So we have to work on, from different aspects, focus on a small problem to, make progress. So in our lab, we mainly focus on the, smart home, like a very low battery-based, resource-constrained IoT devices. And then for that, say, for example, we want to study the malicious traffic, the network traffic generated, right? And then those IoT devices, they may be vulnerable to security attacks. So we want to analyze what network traffic they are sending out or they are receiving, and see if we can differentiate that malicious traffic from the honest, ordinary traffic. Then the first problem we face is a lot of studies recently, they are using deep learning. But deep learning cannot be directly applied on those IoT resource-limited devices for sure, right? So for us, we need to, for example, propose and talk to the domain experts, right? Have the domain knowledge, develop the features that are specifically, lightweight and feasible for those low resource IoT devices. And we need to develop techniques or machine learning, some very lightweight machine learning models, so that they can be applied in those scenarios. So those are some of the challenges we are trying to address. And also, it's important that your security solution be energy efficient, because those devices are battery based. You don't want them to, just spend 90% of the battery just for security purpose, right?
Thank you.
In your opinion, what approaches can be utilized to enhance the safety of IoT?
So I would say there are a lot. I just want to emphasize a few. So just connect to the previous one. I think green and lightweight data analysis tools are important. And another one is recently, some hardware companies, they are also making a lot of efforts to build the security on chip. For example, they can just do simple AES based on the hardware on the chip directly. That makes the operation much more efficient and fast, actually. So that's some techniques we can consider. Another aspect is the IoT devices. They may be distributed all over the places, right? And but the initial setting may work, but over time, right, their firmware or software may be out of date. You need to frequently keep them up to date so that the for example, the older version which have some vulnerabilities can be patched, right? So that's also very important. And also, I think security standards for the IoT manufacturer is very important, so that we can build up we often say how to evaluate if a system or a network is secure or not. It really depends on the most vulnerable point of your system. So make sure you have a common standard way to protect the devices. That would be very important.
Thank you. I know you mentioned that your lab focuses on small IoT devices, but could you talk a little bit about where is a substantive starting point for social good within IoT? So can we utilize these for water conservation, species conservation, etc.?
Yes. I personally don't directly work on that, but I'm aware that there's a lot of efforts trying to utilize IoT, for example, for those social good, like water conservation, species conservation, as mentioned in your question. For example, another example could be the medical wearable devices. They are developed to facilitate people with some disabilities, for example, in terms of their vision, their hearing, their moving, right? Those devices could help them, sense the surroundings and make the decisions like what's your next step more efficiently and accurately. And that can significantly improve people's quality of lives. So that's very important. I have a colleague, he has developed the IoT-based flooding monitoring system for the city of San Jose. And that was very interesting. So in Santa Clara, we have, and our university has the tallest building in Santa Clara. Then they built some sensors or receivers on top of the building, and that can receive the signals and communicate with the IoT sensors deployed. So that's a very interesting project. And one thing I want to mention, take this opportunity, is there is an IEEE conference called IEEE Global Humanitarian Technology Conference, GHTC. And my colleague has been involved in this conference for a few years. And this year, 2022, it will be held at our university, Santa Clara University, in September. And I'm currently serving as a vice chair. So that conference is an international flagship conference, just focusing on bringing together people, just working on the application of technology to address the critical issues for the benefit of the resource constrained and the vulnerable populations in the world. So from previous years, we have papers particularly addressing the water sanitation in African countries. So those projects are very interesting.
Indeed, thank you.
What is the future direction of trust management for cyber physical systems?
So actually, I covered cyber physical system from my PhD. That was a side project that I was participating. In that project, we were working on the amputee who lose their lower limb. So we do need to involve the mechanical part and utilize like biomedical sensors to capture the user's neural signals, and use machine learning algorithm to try to predict the user's movement intention. If the person wants to stand up or sit down or climb stairs, etc. So then we are able to send the control signal to the mechanical limb, the fake limb, then to help people move with their movement. So that's the first cyber physical system that I work on. And actually, through that project, I learned cyber physical systems, depending on which application domain you work on, the problem itself could be kind of unique. So it's different from one domain to the other, very different. So in my sense, based on that project, I would say the trust management, like reliability, could be one important issue. How do you make sure those, because typically we, as computer science, we work on the model part, the cyber part. Once you apply your model to the real world physical, systems, will your model still work? There are many counter cases, right? And you make sure you have to be able to cover those cases. And otherwise, it may cause severe danger to people's life. So we have to be super careful. Then I think trust can play a role there. But again, we have to do real test bed testing, make sure it works in reality. That's important. And I see like you mentioned like data integrity for cyber physical system as well, right? Yes. So yeah. So from the security point of view, it's actually beyond the trust management. Of course, you can, for machine learning algorithm, for example, there is a new direction called trustworthy machine learning. For autonomous vehicle application, for example, we know deep learning model has been applied a lot, and it has been developed very fast over the past few years. But they are facing a critical challenge. Although you can achieve 99% accuracy already, what is 1%? And do you know that when the machine learning model will fail? That's a part we don't understand. Until now, the deep learning model, most of the cases are still like a black box. People know it may work, but you don't really know when it will not work. Then how can you control, right? Make sure it won't crash in a severe, in a special case. So it's kind of untrustworthy. That's why trust modeling can play a role there. But I'm not particularly working in that domain.
Thank you.
Yeah, thank you. One last question, maybe out of box question.
Yeah.
Yeah, if you have a control on the time machine, on computing, where you would like to see yourself?
Yeah, I think this is very, very interesting question. Actually, for all the other questions, I can just directly put my answer, but this one, it took me a while to think. Yes. Well, there are many different, period I want to go to, but I think important thing was like a trend actually in the cybersecurity field. I think many people working in this field may have this observation. So whenever there's new emerging technology, right, the first thing people worry about for sure is not security. People always start from the functionality, the performance of the system, of the network, right? And security tends to be the very last thing to be considered. I think that has been very well demonstrated through the development of the internet or the World Wide Web. When it started, people had the assumption. Nowadays, we see, this is a ridiculous assumption, but back then, that was the assumption they made. That was all the communication entities, participating in the communication, they can be trusted. Which is not true, right? But because of this initial assumption, it makes the functionality, the performance of the network develop very fast. So people start to adopt the concept of the technology. This is important. But this also causes some fundamental issues for security. So nowadays, what we work on, try to address the vulnerabilities. But because that happens in the fundamental design, so what we are doing now, a lot of things is just a fixing or find the particular bug and fix it. But then you may have other bugs as well. So you cannot fundamentally address the problem. At some early stage, I was thinking when we have a new, architecture or the new systems, maybe people will learn the lesson and try to design security from the very beginning. But it turns out, even we have more opportunities, like for example, today's blockchain, it may not be the case still. People pay a lot of attention to the scalability, the throughputs, right, the performance of blockchain. But the fundamental security problems, you have to make trade-offs, right? And when people talk about trade-offs, they start to, maybe we can wait for later time to handle the security problems that again occur. Yeah, that's a dilemma, I would say.
Perfect.
Nice.
So this basically concludes our program for today. Thank you everyone for your time, especially Dr. Liu for your very insightful talk. I learned a lot, especially I need to stop accepting cookies on every single website. So once again, on behalf of IEEE Northern Canada Section Educational Activities Committee, I would like to thank each one of you for your attendance. Please watch your emails for our information for upcoming events. And for more information about IEEE activities, make sure to check out our website, IEEE.org. And thank you. Have a good evening.